Hello everyone. My name is Sandhya Dekota. My MIT student ID is MIT252838. Today, I will be discussing the part A of our group assignment of MN405 Data and Information Management. The part deals with entity relationship diagram. And today, in this presentation, I will be discussing the key concepts, main insights, and important findings from the diagram. Now, I will be sharing my screen. The diagram here is an entity relationship diagram of a real estate agency where an agent sells the property to its client. The main entities here are agent, property, appointment, client, apartment, house, and invoice. The agent here deals with two types of properties. They are house and apartment. Here, the agent has a primary key named agent ID, which uniquely identifies each agent. And the other attributes are agent name, phone, email. So each agent can sell many properties, but every property is sold by only one agent. That means agent has one-to-many relationship with the property. Similarly, each client can purchase many properties, but every property is purchased by only one client. The main entity here is property. So it follows is a relationship with house and apartment. That means a property can either be a house or an apartment. Here, the house and apartment have different attributes, but they have one thing in common, that is the foreign key. That means both house and apartment have a similar foreign key property ID, which links them back to the property entity. Here, a client can book many appointments and can view many properties, but each appointment is conducted by only one agent. Similarly, after a property is sold, only one invoice is generated. That means property and invoice strictly has one-to-one relationship. And after the property is sold, each agent generates the invoice and the invoice is received by each client. So this is the summary of the ERD. From the ERD, it can be clearly seen that the property, each of the primary key uniquely identify its main entities, and the foreign key here are used to maintain the data integrity and establish relationship among each tables. Now, my group mate Sadiksha Dhital will be explaining her part. Over to you, Sadiksha.
Thank you, Sandhya. So, hi everyone, this is Adiksha and my MIT ID is MIT251645. So, after the creation of the ERD, I have done the part 4 of my group assignment. So, first I'll share my screen. Okay, so is my screen visible? Okay. So my part includes mapping ERD to the database schema. As Sandhya explained that we are doing a real estate management ERD, which resembles and look after the sales, client interaction, conduct appointments, and invoices of the property. So from the ERD, we have 7 different entities. So those entities are number 1, it's an agent. Number 2, it's a client. Number 3, it's a property. And number 4, it's an appointment. And number 5 is an invoice. So we have also created the subtype of the property and divided it into 2 other different entities. They are house and the apartment. Similarly, after identifying all these entities, we have also identified the primary keys and also the foreign key. So in our ERD, each entity has one unique key, one unique primary key. So in the agent, it's an agent ID. In client, it's client ID. In property, it's property ID. In house, it's house ID. In apartment, it's apartment ID. In appointment, it's appointment ID. And in invoice, it's an invoice ID. So after that, also not to forget that we have the foreign key in the property entity also. So in the property entity, agent ID, client ID are the foreign key. Similarly, in house, property ID is the foreign key. And in apartment, property ID, also the foreign key. And in appointment, there are three different foreign keys. There are agent ID, client ID, and property ID. So in invoice, there are also three different foreign keys. There are agent ID, client ID, and property ID. So after the data schema and identifying the primary keys and foreign keys of our ERD, I have also explained about their functional dependencies. So for the in the agent, there are three different dependencies. There are agent, each agent ID differently denotes an agent's name, agent's phone number, and agent's email. Similarly, with the client, it also have each client ID uniquely denotes client's personal details. Similarly, property, each property has a, like my fellow teammate had explained, that each property has a single agent in charge of selling it, a single client connected to it, and along with that, its details. Similarly, in the house, property ID, home floor, home bedrooms, home garage, property and the house specific attributes are determined in a unique way of each house record. Similarly, for the apartment ID, in apartment ID, it shows the functional dependency on the property ID. Similarly, apartment unit, apartment floor, and apartment bedrooms. It also says that the property and the apartment specific characteristics of each apartment record are determined in a unique way. Similarly, appointment. In the appointment ID shows the dependency on the agent ID. Similarly, the client ID, property ID, appointment date, and appointment time. So the agent, client, and property involved in each appointment are uniquely determined as is the appointment scheduled. Similarly, the last but not the least, invoice. So invoice ID includes agent ID, client ID, property ID, invoice number, invoice date, and invoice amount. The billing details of the client property purchase is uniquely identified by each invoices. So in the part two, I do have to explain about the normalization too. So the very first thing, what normalization really is. So normalization is commonly used when we are designing a new database structure to analyze the relationship among the attributes with each entity. Since we have already created the attributes with each entity and we have taken an example of the real estate management, for us, we have already created a new database. And the relationship derived from the entity relationship uh, database are normalized step by step to the third normal forms, which is explained as below. So the first normal form. So the first normal form, it has to contain all the atomic values and there are no repeating groups. So in our given ERD of the real estate, all attributes such as agent phone, client name, property price, app, appointment date, invoice amount, keep single values. Here, no attribute shows multiple or the repeating values. Similarly, it also have the functional dependency. Property ID has functional dependency with the property address, property price, agent ID with agent name, agent phone. Similarly, client with a client name and client phone, and the invoice number with invoice date and invoice amount. So the result satisfy the first normal form, but the partial and the transitive dependency still exist. So we have gone through the second normal form. So second normal form only satisfy when 2NF is in 1NF. There should not be partial dependencies. I have highlighted over here and omitted it in the second normal form, but there are still transitive dependencies. So since there is still a transitive dependencies, I have taken it to the third normal form and omitted the highlighted part. So a relation is in 3NF if it is in 2NF and there are no transitive dependencies. Non-key attribute must depend on another non-key attribute. So here is the third normal form where there is an agent ID, agent name, agent phone, agent email. For the client, it's client ID, client name, client phone, and email. Similarly, the property, appointment, invoice. So these all satisfy the third normal form as it omits the transitive dependencies. Thank you so much. Now, for the rest of the part, I would like to call up my friend Puspa for the remaining presentation. Thank you so much.
My name is Puspa Pandey and my MIT ID is 254334. Today I will be presenting my database model building work using SQLite. I converted an ER diagram into related database by using table, primary key, foreign key and constant. First I will show my screen. It's model building. Model building is the process of converting real-world requirement into a organized database design. In this report, real-world objects such as agent, client, and property are converted into database tables. The process starts by identifying entities, then defining their defining their attributes, finally creating relationship between them using keys. Entity identify in this report, the main entities identified are agent, client, property, appointment, and invoice. Property is further divided. Property is further divided into house and apartment. This helps to represent different type of property in a structured way. The ISA relationship is implemented using separate tables for house and apartment. Each reference the parent property table via a foreign key. Each entity shown in ER diagram is converted into separate table using create table statement in SQLite. For example, agent entity become the agent table and all the agent attribute such as ID, name become columns. Using of constant. The constant used in this project include primary key, foreign key, not null and check. This constant help maintain data consistency and accuracy in the database. A primary key is used to uniquely identify each record in a table. In SQLite, the primary key cannot be null. Foreign key are used to create relationship between tables. They connect one table to another and maintain referential integrity. Now for further presentation, I would like to call Simran.
Thank you, Puspa. Hello, it's Miss Simran Khanal, and my MIT ID is 251443, and my presenting part is report generation. I would like to show my slide. Mm. Report generation is the process of utilizing SQL extract relevant data from a database is known as report generation. Its main part is to know the value or goal of report generation is the main extract valuable data, analyze records, and represents them clearly. This allows organizations to monitor activities, manage records, and make informed decisions. This display the query. I have shown the query like query 1 display all agents and their contact details. Query 2 list all properties with the agent who sells them, and query 3 so all client appointments for property viewing, and query 4 display properties purchased by each client. I have also shown the if conditions like property type, house or apartment, you can say in the slide, and if conditions to property price category, grace availability house table, and invoice sales category, and last agent activity based on invoice. Now I like to show the video where I execute the code and it shows the results. First query is this helps the display all agents and their contact details. This helps the agency maintain a complete record of agents and make communications easier. And second query is, you can see the video. This is the first query which helps. This helps the agency maintain a complete record of agents and makes communication easier. And next one is the query 2. It helps the agencies track which agent is handling which property and monitor sales performance. And I have done the query 1 and query 2, and next part will explain by my next friend Sadiq Shah. Thank you.
Thank you, Simran. So the query which I have run is showing all kinds of appointment for the property viewing. So that's the query number 3. So explaining about this query, this is an SQL select query that combines data from 2 tables to show appointment details along with the client names. So let's see. First query over there, the first command is the select. So this tells the database which columns you want to see in the result. So we have kept the C underscore name as a client name, and appointment date from the appointment table, appointment time from the appointment table, and the property related to that appointment. So similarly, client name, this is the main table. And also we have, I have executed the code and gave the command to join the appointment. This join the appointment table with the client table. And this is the join condition. It links both tables using the common attribute client ID. So it displays all list of the client and their appointment, showing the client name, the appointment date, appointment time, and property ID. Each row represents one appointment made by a client. So this is the query I have run for the part 4. So for the remaining part, I'll hand over this platform to Puspa.
And this query is about the condition query, where we put the condition like if or else. This query check the property type such as house or apartment. This allow filtering property based on specific type and work correctly in the SQLite. If the property type is house, it labels it as a house property, and if the property type is apartment, it labels as a apartment property. Now for the presentation, I would like to call Sandhya.
Okay, thank you, Puspa. Muskan, Simran, can you please stop sharing? Now I will be sharing my screen. I will display a video that runs a query from my side. Is it visible? Okay, I will be running a query that is used to display all the properties purchased by each client. So here, first, I will be using the select command. This command is used to display the specified columns such as client name, the property ID, the property type, and the property price. Here, the client name is renamed using as client name to make the output easier to understand. So I have selected these columns from the client table. So the from command is used to specify the table. Now the join property P connects the property table, which is given with the alias P, and the on client ID equals to P client ID links both the tables using the common ID client ID. Okay, this ensures that so when I use on client ID equals to P client ID, it links both of the tables and ensures that each property is matched with the correct detail. So that is the end of our presentation. Thank you for watching. Thank you, everyone.
Thank you, everyone.
Thank you, everyone.
So I'll stop the
Thank you,
recording.
everyone.